Notes. Okay, I'm recording. I have friends at Palm Harbor and Eastlake that teach this class too, and I'll talk about stuff. And my one friend at Palm Harbor is talking about one day in April, making it totally optional for you guys. But if for anybody that's interested, coming in on a Saturday to either Palm Harbor, maybe Countryside, on a Saturday morning and doing a mock AP exam, and we'll feed you and all that stuff. Do you think, and at this, no, not writing names down, but would any of you be interested in that? I'm just wanting to get a feel for it. Would anyone be wanting to come in? Be wanting. Anybody be wanting? Yeah, okay. One person. Yay, Janan. Okay. Is it because Saturdays we don't want to do math? Okay, I got it. I understand. Not everybody brings math on a plane to pass the time. Okay, so like I said, easier day and great practice for what we've been doing. So the only thing new today is working with inequalities versus equations. And these inequalities are like the most basic type of problems, so it's really, really nice. Now, I'm not going to lie. This right here, these properties, if you want to take a second to read them, go ahead, but you might have a headache afterwards. I have read them and tried to think of how to explain them and talked to my friends at Eastlake and Palm Harbor, and we all decided we don't like the way those are worded. Let me put them in English for you. So bottom line is what those two are saying. Really, really simple concept, okay? We have something called a base in exponential and log equations, right? A base, and we call it b. The base in an exponential, like in this one, it would be 5 and 125. This would be 1/3, 1/27, right? Those are your bases. In logs, your bases are that little number, base 2, base 2, base 1/2, okay? So base is common in both problems. So when I'm talking about the base here, which I'm about to, I'm talking about that number. So if your base, your b, is greater than 1, there's no flip. And I will explain this in a minute. Let's just write it down. No flip. And if your b is less than 1, but greater than 0, we flip. Okay? And just write it down so you can reference it, and I'll explain it as we go. So that's a way of saying b is in between 0 and 1. It's greater than 0, less than 1. Okay? It's not negative, it's not 0, and it's not 1. So like 1/2, 3/4, 5/8. Okay? So first thing you're going to do when you look at one of these problems, let me just explain the directions. Find the solution set of the inequality. We're not checking for extraneous solutions or graphing. We don't have extraneous solutions with exponential functions anyway, right? Exponential functions are the easier of the two. There's no like, let's go back and see what x can't be. X can be anything here, okay? Your base will never be negative, but it'll never be given to you as negative anyway, okay? So in this problem, b is greater than 1, right? So we don't have to worry about a flip. So just let's pretend I never said anything, and I'll explain it when we get to example b. So when b is greater than 1, no flip, we're just going to go ahead and solve this, okay? So I'm going to have 5 to the x. Oh, by the way, this is an exponential function. I'm going to always try to do my first method, which is like bases. And by the way, all the problems today, you can do like bases. You don't have to do like log base 5, log base 5. You could. It'll work, but you don't need to. And so I can change 125 to 5 to the third. 5 to the third is 125. And there's already a power up there. So whenever you have a power to a power, in other words, it's one base, 2 powers, we're going to multiply. And we've learned over the last week, even before the last week, whenever you have the same bases here, you can cancel them and then just set your exponents equal to each other. Just like that. And now we solve. I've been encouraging guys all week to try to keep x on the left-hand side. It's going to be really important when we get to logs in a second. So let's just keep, no matter what, trying to keep x on the left-hand side. Trust me, it'll make sense in a few minutes. So I'm going to subtract 3x. That would give me negative 2x. And then divide by negative 2. Guys, don't forget, when you divide by a negative, you flip your inequality symbol. So I know I have not explained to you what this flip, no flip thing means. I'm about to. But that has nothing to do with your normal algebra rules, which include when you divide or multiply by a negative number and your inequality symbol flips. Okay? So that's why I flipped it there. That's your answer, guys. When you do if that had been an equal sign, your answer would have been x equals negative 9. Done. Moving on. This is an inequality, so it's a whole range of numbers. From negative 9, or I should say from negative infinity to negative 9. We never use a bracket on infinity symbols, right? And there's no equal to sign here, so we keep the parentheses. Otherwise, we'd make the bracket. That's it. That's the answer. Done. Easy. Okay? Question on that one? Eli, your birthday's tomorrow. Did you know that? It is. I saw it on Portal, so that must mean it's true. Okay, so again, with inequalities, we have to remember, okay, check the base. In this case, our base is between 0 and 1. So we are going to flip. So what does that mean? That means before you even start working on the problem, I would do it, just so you don't forget. That's it. That's the only difference about anything else we're doing today. The rest of the problem, exactly like what we just did. Okay? Now, we are going to try and get like bases. And for some reason, not some reason, just traditionally, students over my almost 30 years of teaching have struggled with fractions, even at this level. Like, you guys can do the hardest things when you see a fraction and you just like want to cry. We can change that 1/27th to have a denominator of 3, because 3 to the third power is 27. So I'm going to say 1/3 here, and 3 to the third power is 27, and it doesn't hurt the top. 1 to the third power is still just 1. So 1/3 quantity cubed is 1/27. But don't forget, we have an x minus 3 up there. Now your bases are the same, right? Cancel, cancel. We flipped it in the beginning so we wouldn't forget, and now we can just set our exponents equal to each other. I'm going to go ahead and distribute now. And we can state this. And solve. And solve. I know that a lot of you don't like to have a negative x, especially in an inequality. I'm not going to mark you wrong if you bring the x over here. I'm just giving you a heads up that if you start getting in this good habit of keeping x on this side, it's going to help prevent mistakes when we get to the logs, which I'll show you in a moment, okay? So I subtracted 3x from both sides. I will subtract 9 from both sides. And I'm going to have to divide by a negative here, which flips my inequality symbol, and that's fine. It's okay that it's doing that. We're following all the rules. We flipped in the beginning, and then if we have to flip again within the problem, we do that, okay? And that's the answer. Wait, yeah, that's the answer. So from negative infinity to 18, and on this one we would use a bracket, right? Because we're including the 18. Okay, so far? Easy, right? The first half of this assignment, you don't have to worry about extraneous solutions or anything. Okay. Now, I am not leading you into like, oh my gosh, this is so much harder. It's not. There's just one more thing we have to think about as well. All right. So again, we're going to find the solution and check for extraneous solutions. Now, when we check for extraneous solutions with log equations, that doesn't mean I need to see off to the side where you plug in, you show the work. It's like we've been doing all week, where you just kind of have to know, what is my restriction here? anywhere we see an x, we have to say that that x has to be greater than 0. So in this problem, you're just kind of making a mental note. Whether it's now or at the end, I don't need you to write it, but this x means, because it's in a log, we cannot have a 0 there and we cannot have a negative number, right? So I'm just going to keep that in the back of my mind. Now let's solve the problem. The same rule applies with logs, that if I have log base 2 on the left side and log base 2 on the right side, they can cancel. There is one little bit of cleanup on this problem, which is to move that 2 onto the x, right? Apply your power property. And as I told you before, you're never going to be given a problem that's like got log base 2 on the left side and a log base 7 on the other side. They're going to be the same base. But now that we are there, bye-bye, bye-bye. Square root both sides. And I get plus or minus 3 is greater than x. So let me write this with the x on the left-hand side. X is less than 3. X is less than negative 3. Now, negative 3 is extraneous, right? We talked about it. If I put a negative 3 in there, or anything less than negative 3, right? Negative 4, negative 5, they're all negatives. That makes it extraneous. It doesn't fit in here. But 3 is good, right? But, so don't write this because it's wrong. Don't write this. Is this my answer? On the last two problems that we did, it would have been, right? That matches this. All the numbers less than 3. Why is this not the answer? Yeah, x has to be greater than 0. So you have to respect the fact that before, it wasn't just this problem, right? It was a log problem before it was that problem. So we want to say, what is the range of answers we can have? We can have from 0, but not including it, right? From 0 all the way up to 3, not including that. Those are the solutions. We can't just say all the numbers less than 3, because the numbers that are less than 3 include 0 and a bunch of negative numbers. And we're not allowed to have 0 or any negative numbers in a log problem. Okay? Let's do it again. Oh, I forgot to mention it. Sorry. B is greater than 1 here. Right? So there was no flipping. And B is greater than 1 on this one as well. Still no flipping. Same rules with logs. And we'll do a flipping one in the last problem. Okay. So in that first example, we had logs on both sides. Yay, we canceled. In this one, notice we don't have logs on both sides. This is where you have to rewrite your log in its other form. We did this 2 to the third equals this. Here is why, this is the moment right here, where you are going to learn why it's so important to keep the x on the left-hand side. So if I, don't write this because it's wrong, if I wrote this, 2 to the third is less than equal to 2x plus 1, that's different than what I'm going to write, which is 2x plus 1 is less than or equal to 2 to the third. Look at the difference in those two problems. The alligator is eating the 2 to the third. The alligator is eating the 2x plus 1 in this one. You want x on this side to match up with your symbol. That is why we want to get in that habit, okay? Can you write it like this? Yeah, but then you'll have to remember to flip it right there to make it match what it's supposed to be, okay? And that's it. We just solve it from there. Do you guys want me to ask him to turn it up? Yeah? Okay, subtract 7. Subtract 1, sorry, get 7. Divide by 2. That's 7 halves or 3.5, whatever you want to write it as. Now don't forget, back to 2x plus 1 up there. It has to be greater than 0. So confusion first period was, yeah, but it says less than or equal to there. Separate part of this problem. We're looking for what x can't be because it's a log, not what x is because we solved it. Okay, so 2x is greater than negative 1 is greater than negative 1/2. All of our x values that we got here have to be greater than negative 1/2. Because if I plug a negative 1/2 in or anything less, I will get a negative number or a 0. So that is my range of numbers from negative 1/2, not including it though, up to 7/2, including it because it's got the bracket, the equal to sign. So negative 1/2 to 7/2 would be my solution set. You get that? Yes, Lexi. Are you talking about right here? Wait, what? Wait, what? That's right. You will never see, let me just make sure, you'll never have a 0 there. Right. That's correct. Wait. Okay, let's make sure we're saying the same thing. You can't have a 0 when you plug a number in here, right? Here? If I plug a negative 1/2 into here, 2 times negative 1/2 is negative 1, and negative 1 plus 1 is 0. So I can't have negative 1/2 or anything. Oh, you're saying, okay. Okay, now I'm getting confused. Greater than negative 1/2. Yeah, okay, right. X, we're both saying the same thing. That's what this says. X can be anything greater than negative 1/2, including 0. Because if I plug a 0 in here, what do I get, sweetie? 2 times 0 is 0, and 0 plus 1 is 1. It's just X. Yeah. So if I plug a 0 in there, I would just have a 0. Do you see it, Julia? Yeah. Are you sure? I'll come and chat with you guys to make sure, okay? All right, that's the final answer for that one, though. I'll make sure. And if anybody else is still confused about it, I'll come and chat with you. Okay, last one. B is less than 1 and greater than 0, right? My base is 1/2. There's no cleanup to do. I have logs on both sides. I get to do that. Let's not forget that because our base is less than 1, greater than 0, I have to remember to flip. And there we go. Subtract x, add 3. So x is less than or equal to 8, but let's remember, x plus 5 has to be greater than 0, and 2x minus 3 has to be greater than 0, right? Everybody agree with me? We have 2 x's in there we have to respect. So x has to be greater than negative 5, and x has to be greater than 3/2 or 1/2. The trick when you have more than 1 is to take the bigger number, because all the numbers that are bigger than 3/2 are definitely bigger than negative 5, right? All of these numbers are greater than that, and you have to respect both of them. So we don't really care about that one. This is the one that's going to kind of dictate. So we'll be from 3/2 to 8. Those are the only solutions that will work in this inequality. Did that one make sense, Lexi? Yeah. That's one too. Okay. I'll come. 1 through 15. Odd. 4 exponentials, 4 logs. Yeah. And then, oh, sure. You want to pass up there to see? Okay. Yeah, I just never stop messing with this thing. Of course. Okay. Here you go.